Yeah, good morning again. She'll start with the problem today. See, what is the question here? Find Z transform of the signal x of n. It is given by 3 into 2 pi n u of minus n using appropriate properties. Okay. Now, here one thing that you need to be careful about I'm explaining now. And this is not a usual signal. You may think that okay, it's 2 pi n it is u of minus n. Okay, but it is not actually in the required form. Okay, so we need to understand what is that required form we are talking about. Okay, so let's see this. Which form we can apply Z transform directly, which form we cannot apply Z transform directly. So needs to be understood. Okay, now what we can do here, let's see. Fine. I hope there are 35 participants now. I hope I should. Yeah, let's go. I cannot just keep waiting for the latecomers. Yeah. Why it is valid? This is a basic signal. Which signal is this? Standard basic signal. Okay. This is a power n u of n format. A power n u of n. In place of a, you have 2. That's it. Okay. If this is so, this is valid signal because this signal we know, and we know the standard and we know the Z transform of this basic signal. What is Z transform of this basic signal? The Z transform of this basic signal is Z by Z minus 2 with ROC outside the circle with radius 2. Outside the circle because it is right side. This is very much understood. Now, so this is valid. This particular signal is being referred to as invalid means it's something not in the proper form. Invalid means it's not an invalid signal in a right sense. Okay, this is valid because we know how to obtain the Z transform. We don't know how to obtain the Z transform for this. That is the concept. So what we need to do in that case here, here you have plus n, here you have minus n. So since this is the same signal, which signal? Positive time exponential. Since this is positive time exponential, you cannot have this negative attached with only one n. So there should be a negative sign attached to this also, or there should be no negative sign here also, as in this case. Get that point? So this is invalid. We cannot just go ahead with this because we have a minus sign here. We have plus sign here. So which is not good, which is not a proper form to go with our Z transform. Okay, so if this is minus n, you can try get this also as minus n. We can try get this also as minus n. How to do that? How to get this as minus n? In place of a, let any number be there. In place of a, let any number be there. Okay, but how can I make this minus n without actually changing the given signal? When I try get this as minus n, okay, you're not supposed to change the actual signal, so that needs to be kept in mind. Okay, I just cannot bring and attach a minus here. I should be bringing a minus sign here in such a way that, okay, even after bringing minus sign here, okay, I can bring back that to this given form. What way we can do that? See here. Okay, what way we can do that? It is half power n. Half power minus n I can do, isn't it? Half power minus n. Maybe I can take. Okay, that's not possible. I cannot share another document when I'm sharing this. Well, it's not bother. We just can do this. Okay, we just can do this by making this 1 by 2. Soon after you make this 1 by 2, this would become minus n. Okay, and I'm not changing the given equation. How I'm not changing the equation? I've done 1 by 2 to the power minus n, and if you again invert that, it would again become 2 power n. So in that sense, we have not changed the what the given signal in this case. Fine. So we can make this as minus n by making this 1 by 2. So such modifications need to be done to the given signal. Fine. I'm going with few such examples. Okay. But be careful about what we're doing. Now, this is also invalid. How this is invalid? Here is minus 1. Earlier, here is plus, here is minus. Now, here is minus, here is plus. So, since this is one standard signal, that is what? Positive time exponential. Okay. Since this is positive time exponential, you cannot have negative here and positive here. And this cannot be called as negative time exponential because this is on the negative side. Sorry, this cannot be called as positive time exponential. This is on the negative side. Understand that point? So one thing that you should understand, if we have a standard signal, if you have a minus here, here also you need to have minus. Okay, otherwise both should be positive. Both should be positive or both should be negative, then it's okay. You cannot have one negative and one positive. You cannot have one negative and one positive. Okay, so these two signals are referred to as invalid signals, but we need to bring them to the proper form. How can I bring this to proper form? Can I make this negative? No, I cannot make this negative. Can I make this positive? Yes, I can make this. How to make this positive? Again, in place of 2, just have half. It would become plus. So half power n u of n, a valid signal. Get that point? Similarly, here it's 2 power minus n, u of minus n. So since both n's are minus here in this exponential, okay, so we can say this is a valid signal. Understand? Now, see, this is interesting. Again, this is interesting. Here we have minus, here we have minus as in the previous case. Okay, but there is an n introduced, but this n is not minus. This n is not minus. Even then, it is referred to as a valid signal. Even then, it is referred to as a valid signal. Why? See, n is a different signal. This is a different signal. This is an exponential signal, mind. This is an exponential signal. Okay. And this is n being attached to that signal. This n being attached to this signal is not a basic signal. And we don't know what to call that signal as. And it is not ramp, mind you. It is not ramp. Ramp is nu of n. If it is nu of n, both the n's has to be positive. Or minus n, u of minus n is fine. But this n is entirely a different signal, and this is entirely a different signal. So if there are two different signals, let's not bother about sign of n. But if it is the same signal, okay, then the n should have the same sign. Yeah, the n should have the same sign as in these cases. Okay, so we shall solve problems. Maybe things will get more clear to you. Fine. What is the problem that I want to discuss? Is this. Now, is it in a proper form so that we can apply Z transform directly is the question now. Okay, is this in the proper form? No, it is not in the proper form. Why? Why? Because see here, you have 2 power plus n and you have minus n, and this is the same signal. It is one signal in which one n is positive and the other n is negative. Okay, so this is not allowed. So what we can do without changing the signal, so we can make this half to the power minus n. We can write this as half to the power minus n. Why did I want to take this as minus? Because there is a minus. I cannot eliminate this, but I can bring a negative sign here by making this half. Is that okay? Now, that is what one needs to take care of in such problems. So, this can be written as x of n equal to 3 scalar, which will not matter here. Okay, keep that aside. Yes, in the result we need to bring this. Okay, but here it's not of importance. Now, see here, 2 is made half. Soon after the 2 is made half, 1 by 2. So this n becomes minus n, and since we have minus here, here also we have minus. So this is a proper form, and we can directly go for getting the Z transform. But Z transform using the appropriate properties. Z transform using the appropriate properties we need to do. So it is using the properties. So identify the basic signal here. Identify the basic signal here. Which basic signal is hidden, which we need to extract, okay, and start with applying the Z transform. From there, in every step, we shall try reaching this particular given signal. But to begin with, we shall approach the most basic signal available here. Which is the most basic signal? You can say U of n. No, it's not U of n. It is half power n U of n. U of n is step, but there is this exponential. Understand that? So we have to take exponential along with this U of it. So which is the signal we are approaching? So this is the signal we are approaching. What is that? Half power n U of n. Half power n U of n. So what is the Z transform of half power n U of n? It is Z by Z minus half. And since this is a right-sided signal, okay, the ROC is outside the circle with radius half. Many a times we have seen the same thing we are referring to all these days. Okay, so you should not have any difficulty in understanding this. So this is a different form of representation. This is a different form of representation. Why? This is take this equation is taken from another book written by Uday Kumar. The author is Uday Kumar. He uses this transform pair representation. Okay, what is another transform pair representation here? Zx of n is equal to x of n. You can say the Z transform of this is equal to this. This is one way of looking at it. Another way of looking at it by giving the arrow. Now, what property do we use to? We need to use time reversal. They have told that. Now, if you don't see that, if you just see this, okay, what is given in the problem? There is a minus here. There is a minus here. So, what are we doing by introducing minus there? What are we doing by introducing negative sign? So we are time reversing. We are time. Why we are attaching negative signs here? Because in the given problem it is there. Because in the given problem it is there. This is as good as this. So we have not actually changed the given function. So it is the same, but we have introduced minus sign on both sides. Since minus sign is there, I need to introduce minus sign here and here. So introducing minus sign here and here is negating n. So negating n is taking the reflection of the signal given. Taking the reflection of the signal given, in other words, can be referred to as time reversal. Reversing the time. Understand that? So after time reversal, how does it look like? So the property that we need to use is time reversal. In time reversal property, what happens? If you have x of n, it looks like x of z. If you have x of minus n, in this x of z of x of n, okay, replace z by 1 by z. Again, something that we have seen in the earlier problems. Z transform of x of n is x of z. So what is Z transform of x of minus n? It is x of 1 by z. Okay. In the Z transform of x of n, whatever x of z you obtain, in that you have to replace z by 1 by z. Now see here, this signal is in this place. Half power n u of n is x of n now. So this signal is in this place and this signal is in this place. That means Z transform of half power n u of n is z by z minus half with ROC magnitude z greater than half. Now negate this. Therefore, Z transform of half power minus n u of minus n is what? In the Z transform here, we have to replace z by 1 by z. So that is what is done here. See it carefully. In place of x of n, we have this. In place of x of z, we'll have this. So if you have this in this place, understand, in this place you're having the time reverse signal, half power minus n, u of minus n. Then its z transform is this z transform of x of n, but the z replaced by 1 by z. Okay, since we are replacing z by 1 by z, okay, in ROC also this z needs to be replaced by 1 by z. So this needs to be understood. So if you are doing any operation on Z transform, Z domain signal, then that operation on Z domain signal needs to be applied also to the region of convergence, because region of convergence we talk in Z domain. Understand? So since in the Z domain we are replacing Z by 1 by Z, okay, in region of convergence also Z needs to be replaced by 1 by Z. These z's are replaced by 1 by z. This z is also replaced by 1 by z. Okay. Now, how does this look like now? Therefore, half power minus nu of minus n comes like this. Okay. So if you replace z by 1 by z, this is how it becomes. And if you replace z by 1 by z, this is how the z looks like now. Earlier it was z greater than half. Now it has become z less than half. Why it became z less than 2 rather? Because we have a negative time exponential. Since it is negative time exponential, the region of convergence needs to be inside the circle with radius 2. Okay. Earlier it was outside the circle with radius half with the given function. Now it is inside the circle with radius 2. Understand? Okay. So therefore we can say the Z transform of this. Now this 3 was not taken care of here. The 3 is not taken care of. If this 3 is taken care of, that 3 should come here. So that is what is done. So this is not this given signal. The given signal is 3 into half power minus n u of minus n. So that 3 is brought here. So you may say this is not the given. No, this is the given signal. What is given? 3 half power minus n u of minus n. But what is given in the actual problem? It is 3 into 2 power n u of minus n. That signal is this. We're just looking at in a different way. That's it. So that once we take this 3 into consideration, since this is a scalar, that scalar should come along with this z transform. So the 3 is here. Anyways, that this 3 anyways is not going to change the region of convergence. So this is how we find out the z transform and region of convergence for the signals, where the signals are not directly given the proper form. So we need to get them into the proper form before we start approaching the problem. Get this point? So we shall see 2 more such problems, and I would rather like you to analyze that. Now this is the signal. So there we were negating. There we were talking about negating n. Here, what is the problem? Everybody understand this. Just observe a bit and then say where I should be modifying the signal. Yeah, let me go. Here, this u of n is associated with this half power, but this is shifted version of u of n, and this is not shifted version of n. Understand? So how to get these two into proper form? So you should be able to make this half power n minus 3 u of n minus 3. It is not possible to take this minus 3 off from this signal. So introduce n minus 3 here in the power. That's possible. Okay. So it's half power n minus 3 u of n minus 3. It's a proper form. But half power n u of n minus 3 is not a proper form. Everybody understand that? So since this u of n is u of n minus 3, I want this half power n to be half power n minus 3. And this n is not a matter. This is a different signal. So this is one signal, and in one signal, this n is not shifted, this n is shifted. No, that should not be the case. So let's have this also in the n minus 3 form. So how to do that? How to do that? Can you bring this to n minus 3 form? Can you bring this to n minus 3 form? How can we do that? But after getting this n minus 3, this given signal should not change. The given signal should be the same. What we do to get this as n minus 3 in one step ahead. So if you go one step back, we should be able to get the same signal as given. So how to do that? How to do that is the question. Yeah. See here, let me introduce minus n minus 3 here. How to do that? Let's have half to the power. See here, 3. If you have half to the power into half to the power minus 3 is what we have. What is half power 3 into half power minus 3? Half power 3 into half power minus 3 is 1. Half power 3 into half power minus 3. So it would become half power 0, half power is 1. So what we are doing is, we are multiplying this signal by 1. We are multiplying this signal by 1. What is that 1? 1 is half power 3 into half power minus 3. Where is that half power minus 3? Half power minus 3 is combined here now. See, this minus half power minus 3 needs to be brought. So that half power minus 3 we have brought here. Since this minus half power minus 3 is brought, we need to have half power 3 as compensation for that this half power minus 3 brought along with this signal. Is everybody okay with this? Why did we do that? We did that because this is u of n minus 3, but this is half power n, not a proper form. So to bring this to the proper form, okay, what did we do? We multiplied the given signal by half power 3 into half power minus 3. So that half power minus 3 combined with this signal gave you half power n minus 3. And this is a scalar now. This is a scalar. This will not harm you. This will just be there aside. Okay, this is not going to trouble you anymore. Fine. So this given signal, okay, is now 1 by 8 into n into half power n minus 3 u of n minus 3. So this is the form we need to get into. Now if you go a step back, it looks like this, and if you go a step back, it should look like this. So that means we still can bring this particular form to the given form. So that should be the case. It's not that with the intention of making this n minus, you will change this. No, you cannot make this half power n minus 3 without this 1 by 8. Because if you are bringing half to the power n minus half to the power minus, you need to have half power 3 to compensate that. So this is compensation factor. Get that? So given signal first needs to be brought into this form. Now what is the standard signal that you will see? The basic standard signal. U of n is not, U of n is, yes, it's a basic signal, but there is another basic signal that you need to catch hold of, and from there on we need to build the solution. Yeah. Which is the standard signal that we need to catch hold of? This is half power n u of n. Half power n u of n is the positive time exponential, right? So there is a positive time exponential. That positive time exponential is half power n u of n. Understand? Now let's start from there. Very similar to what we did in the previous problem. The first step, we are identifying the positive time exponential as the basic signal, and we are applying Z transform on that. Okay, so the Z transform of half power n u of n is Z by Z minus half. Okay, with region of convergence being outside the circle with radius half, since this is positive time exponential. Fine. Now what we need to do here to get n minus 3? What operation needs to be performed on this so that I can get this? Which operation? Is it time reversal operation? Is it time reversal operation? No. What operation is that? This is time shift operation. Time shift. So this signal half power n u of n needs to be time shifted so that I can get this. So what we are trying to do is, we first start from here, then slowly we need to get to this in step by step manner. We need to get this left hand side to this particular form, And finally, when this left hand side this would be here and the right hand side would be the answer for this Z transform. Okay, so we are going with time shifting now. So if you time shift this, we shall take care later. This n we can take care later. Understand? So now what happens? Using time shift property, I told you that because n is n minus 3 now. So earlier half power n u of n was there. Now that would become half power n minus 3 into u of n minus n. For that to happen, we need to follow time shift property. And what time shift property tells you is this: if you have x of n, it is x of z. What if you have x of n minus n naught? The z transform of x of n minus n naught would be the z transform of x of n being multiplied by a factor z to the power of minus n naught. This z to the power of minus n naught is coming because you have a shift by minus n naught. Get that point? Okay. So this is how it is going to look like. Okay. X of z is the z transform of x of n. So this is z transform of z by z minus half is the z transform of half power n u of n. But since half power n u of n is shifted by minus 3, so there should be a factor z to the power of minus 3 associated with z transform of half power n u of n. The ROC would remain the same. The ROC would remain the same. I think you all can give your attendance. Otherwise, it's a problem. We're not able to do it in the end. So do it now. We are left with 10 minutes. We'll continue with this. Okay. Give your attendance. So it very clearly tells me that there are so many people, maybe 10 odd people, just log in and go off, it seems. Because when I'm asking you to give your attendance, not everybody is giving the attendance there. You are 40 to 46 members, but only 36 have given. That should not happen. Be honest in learning. Okay, only 38 have given. 43 is the number that is showing here. Logged in is 43, given is 38. That means 5 people are not there in the session, but they are logged in. No problem, no problem. I don't mind. I don't mind because I want to concentrate on teaching. You also should concentrate on what you're learning. Let's not bother about that. Yeah. Now, now, half power n minus u of n minus 8. It's a time shift operation. So in the z transform, what we had for half power n u of n, so that x of z needs to be multiplied by z from minus 3. Now this is not the final signal. What is the final signal? Final signal is this: 1 by 8 into n into half power n minus 3. So we need to bring this n now. We need to introduce this n. Okay. So if we introduce that n, if I introduce that n here, if I introduce that n here, what should happen on the right hand side? So which property comes into picture if I multiply n here? Which property? That is, multiplying n to a signal is differentiation in Z domain property. What is differentiation in Z domain property? Is this? I didn't write that. Yeah, maybe next it will come. What is done in this step? Anybody? See here? What is done in this step? They have just see, one Z is in negative power, the another Z is in positive power, right? So they're trying to get this Z also as positive power of Z. Okay, so what did they do? They brought this Z cube to the denominator. So Z cube in the numerator would become 1 by Z to the minus 3 would become 1 by Z cube. Okay. So when it is 1 by Z cube, this Z and that Z cube, if you can cancel that 1Z in Z cube, it would become 1 by Z square. So 1 by Z square is being multiplied to the, so the Z square is being multiplied to the denominator. Understand that? So it is Z cube minus half Z to the power 2. Okay, Z square. Z cube minus half Z square is what going to become. Okay, so this would still be the same. Now we shall bring n here. So if we bring n here, what would happen to the right hand side is the question. Okay, that we were discussing. So which again you need to think of the properties. These are all solving the problems by referring to the property. So which property holds good here? As I said, it is differentiation in Z domain. So the differentiation in Z domain property tells us what? It tells us this. Okay, if you bring n, fine. So then you have, it is on the right hand side, it is minus Z d by dz of what we had, the Z transform for this. So Z transform of this needs to be now differentiated with respect to Z, and a minus Z needs to be multiplied to this. Get that point? So this is, I didn't write that differentiation in that general form of the property. I didn't write. This is being directly done. Okay, n is brought. So since n is brought, it is by differentiation in Z domain property minus Z d by dz of what we had previously. So n introduced. So n is minus Z by d by minus Z into d by dz. You can say. Understand that? Okay. N is minus Z into d by dz. So soon after you bring n, what is happening here? It's minus Z d by dz of this. So minus Z into differentiation of this with respect to Z is what is going to come here. Soon after n comes here. So n, the Z transform of n is minus Z by d by dz of this. Fine. That is what is done here. Minus Z d by dz of Z transform in the previous step. Fine. So if you differentiate this, what would happen? Can you differentiate that? Okay, I've done that. So this is how the differentiation would look like, and minus Z taken into account would make it look like this. But this is not the. I concluded it before going for one more step. What needs to be there in the next step? What needs to be there in the next step? So that 1 by 8 is not taken care of, right? So if that 1 by 8 is taken care of, that 1 by 8 should come here. You understand? So that's, see, there is 1 by 8 here. So there is 1 by 8. This 1 by 8 needs to be considered. So that needs to be considered before we end. So I have ended the problem here, but that 1 by 8, everybody. So take 1 by 8, maybe in the next step. So that 1 by 8, therefore 1 by 8 into n, half power n minus 3, u of n minus 3 would have the Z transform 1 by 8 times this. Okay, 1 by 8 times this. Now, let's go on with another signal now. Which signal is this? It's a sinusoidal signal. So this n is there. So this is differentiation in Z domain. This leads to differentiation Z domain. Let's keep this aside. Okay. So with this not taken into consideration, it is sine omega naught n u of n form. Sine omega naught n u of n form. But in sine omega naught n u of n, this n is positive, this n is negative. Yes or no? So how to deal with that? How to make this minus n? How to make this minus n? So if you make this minus n, what is sine minus theta? Sine minus theta is minus sine theta. Isn't it? Sine, I'll be introducing minus here. So once I introduce minus here, it would be sine minus theta. Sine minus theta is minus sine theta. So that minus would be taken care of here. So this is what is being done here. So since there was a minus here, I wanted a minus here. But if you bring a minus to compensate this minus, we have a minus here. So just see, just operate with this, you should get this back. That's the idea. If you operate on this, you should get the same signal, because we should introduce a minus sign here, but at the same time you should understand that the given signal is not changed. So what is it? What is sine minus theta? Sine minus theta is minus n. Sine minus of pi by 2 n would give you minus sine pi by 2 n. So minus sine pi by 2 n, there is another minus here. So that minus would go off. What would remain? What would remain? What remains is sine n sine pi by 2 n into u of minus n. So it is the same signal. It is the same signal, but we are able to bring this minus and compensate this minus by attaching a minus sign here. Get that point? So if you don't understand, just go backwards. Just go backwards. If you go backwards, we're able to get this. But what was the intention of doing this? There is no minus here, there is a minus here. So we need to bring a minus. So we brought that minus here. So to compensate that minus, we have a minus here. So this is the proper form that we need to move on with. Understand that? See here? We know the standard signal, sine omega naught n u of n. So, but in place of omega naught, we have pi by 2, that's it. So the Z transform of this standard signal is, in place of omega naught, I've just put pi by 2. So this is something that we know. We have solved this in the class. What is the Z transform of sine omega naught n u of n by expressing sine omega naught